Welcome to Real Science Questions,
the podcast where we get real, questioning science.
Have you ever wondered how lightning works?
Where on Earth gets hit by the most lightning?
Have you ever heard of lightning bolts, and are they even real?
How can we minimise our chance of being struck by lightning? We'll be speaking to a lightning survivor later in the episode.
All of that and more coming up on today's episode, What the Lightning?
So, lightning, we don't really tend to talk about it very much, and it's one of them things we experience from a young age. Our basic knowledge of lightning is that it happens during thunderstorms, and we usually hear a loud noise or thunder with a strike.
And you may have also counted the number of seconds in between the flash of light reaching you, which happens almost instantaneously, and the thunder reaching you, which is slower because the speed of sound is slower than the speed of light. If you times the number of seconds in between the light and the sound hitting you by about 340, then you get the distance of the lightning away from you. 3 seconds would be about 1 kilometre, 5 seconds about 1 mile.
It's one of them cliche things that everyone can relate to, you know, like counting with the mum like, at the back door. How far away is it? So, Pip, what is lightning?
Okay, so lightning is essentially just an electrostatic discharge. But for this discharge to occur, first you need a build-up of separated positive and negative charges. And they have to be separated by something that's insulating. And in the sky, this is air. So air is not electrically conductive normally. So this acts as an insulator. And there's 3 kinds of lightning that you can get, either within one thundercloud, or between 2 different clouds, or between the cloud and the ground, which is the one that we're probably most familiar with, where you get these bolts of lightning coming down. And the exact process, how these positive and negative charges build up, is not really understood. One reason being it's pretty hard to take physical measurements inside a thundercloud, because if you can imagine you put some sensitive electric equipment inside it, it's just going to get fried.
Sure.
But one of the theories is that you have water droplets in the cloud and also some small ice crystals, and also sort of like slushy hail. And these will collide with each other and also with gas molecules in there. And as they bounce off each other, they kind of give and take electrons. So this is the same concept as when you rub a balloon against your hair, and you get this static electric buildup. You give electrons to the balloon, it takes them from you, and so you end up positively charged and the balloon negatively charged, and that's why your hair is then attracted to the balloon. But in the thundercloud, the little water droplets and ice crystals become positively charged, and these kind of rise up to the top of the cloud.
Okay.
And the slushy hail gets a kind of negative charge and goes down stays at the bottom of the cloud. So then, as I said, discharge can either happen in between this cloud or another cloud, or it can come down to the Earth. And the reason it can come down to the Earth is because as the cloud moves across the Earth, this negative charge at the bottom of the cloud induces a positive charge in the Earth, so it kind of pushes away any negative charges in the Earth. They're repelled by the negative charge of the cloud, and it makes the Earth more positive. And this includes you, if you're standing on the Earth. Underneath a thundercloud, you will also gain this positive charge, which is one reason why it's very dangerous to be outside in the storm. But then the actual mechanism by which lightning strikes come down and discharge this buildup of charges is also not super well understood. But essentially, somehow from the cloud, a sort of plasma channel gets formed in the air. And plasma is essentially when a gas becomes ionized. So normally the molecules have their electrons really closely bound to them in a gas. But in a plasma, some of the electrons become free and they're able to just move around, and then it becomes conductive, just like a metal. So essentially the cloud starts making these channels of plasma that come down to the Earth, and these can like split out into different branches, which is why you get this forked lightning.
When it's trying to kind of find its path through, the easiest path through the medium, which is the air, like you said. So that's why you sort of get the splintering effect.
Yeah, exactly. And so eventually it'll reach the Earth, and once it does that, negative charge from the cloud can come down, and also positive charge from the earth can go up to the cloud. And this is when you get your lightning bolt. Suddenly, a lot of charge is moving, and the voltages are super high. The temperature in these plasma channels rises to above 27,000 degrees Celsius. So it's super hot.
Mm-hmm.
And this is why they give out light, actually, because they act as a black body. And a black body in physics is essentially, it just means when something gets hot, it starts giving out radiation, light radiation. You can judge how hot something is by the color that it is. So if you think of something that's red hot, it's hot enough that it's giving out red light, which is the lowest energy visible light. But then if you have something that's white hot, that's hotter than the red hot thing. Because as well as the red light, it's also giving out green and blue, so it looks white. And the lightning is actually so hot that it even gives out ultraviolet light.
No way.
Yeah, so it means if you're close enough to a lightning strike, you could actually get the same effects as you do from sunburn. But it probably wouldn't be the biggest of your worries.
So, Pip, why do the molecules in the cloud separate?
Yeah, so another condition that scientists think is necessary for thunderstorms is the hot and cold air mixing. So if you know that hot air rises, this kind of drift upwards is what carries, or is believed to carry, the smaller water droplets and ice crystals up in the cloud, whereas the bigger slushy ones stay at the bottom. And this you can actually see if you look at when most lightning occurs during the day. It actually peaks worldwide around 4 in the afternoon. Essentially because by this point you've had enough time for the Earth's surface to heat up and make that hot air, which then can rise and mix with the cold air.
So I guess there's going to have to be certain conditions which make lightning more likely then?
Exactly. And this kind of brings us into talking about the next thing. So a friend of mine that grew up in Venezuela told me about a lake there. And you can stand on the edge of the lake and look out and see lightning every day, all the time. There's just a never-ending storm there. So we looked this up, and it's called Lake Maracaibo, and it's in northern Venezuela, just below the Caribbean Sea. And essentially there, they just have the perfect conditions for forming lightning, because you have the hot air from the Caribbean Sea coming in. And then this lake is surrounded by mountains on 3 sides of it, with a river coming in. So that brings the cold air from the mountains meeting the hot air of the sea. And you have lots of water in the air because you've got the sea and the lake. So there's plenty of water around to form the clouds. And yeah, in this place, you have lightning on average 300 days a year. And during a storm, I think 28 lightning strikes a minute on average.
That is incredible. 28 strikes a minute. Wow.
Yeah, so just about 1 every 2 seconds.
I saw this guy who goes out to the lake every day just to take pictures of it. He feels like it's his obligation.
Oh, wow.
Yeah.
Yeah, and that's the thing, like, if you take a photo of lightning, you'll never ever get the same photo twice. Like, it's such a random...
That's it.
Event. The patterns of the lightning are so random.
Yeah.
Oh, exactly, yeah. So I guess that would be the best place to really study lightning then, wouldn't it?
Yeah, so a lot of scientists have been there to study why this place has so much lightning, and that in turn has led to a lot of the understandings about how we need this hot and cold air mixing and a lot of water vapor in the air. Other studies that maybe thought that the lightning was due to maybe methane releases from the surrounding swamps of the lake. But it seems like these studies are kind of inconclusive and probably don't really relate to the annual trends in lightning. So yeah, probably it's just because it has this perfect mixing of hot, cold air and lots of water.
Perfect conditions, really. So I suppose when we talk about studying lightning, there's still a lot we really don't know, isn't there?
Yeah, absolutely. Like I said before, how exactly this static electricity gets built up in the clouds is not understood.
Mm-hmm.
How these plasma channels get formed is not understood. There's other weird phenomena that stumbled across as well.
Yeah, sure. It was only recently that they discovered that it helps to fertilize soil as well, a lightning strike.
Yeah, so how exactly does that work?
So it will fuse nitrogen molecules to oxygen, creating nitrogen oxides, and then it'll sort of dissolve into nitrates, which dissolve into the ground.
Does it just fertilize like one little patch of soil, or can it actually fertilize a whole field?
I don't know if it'd do. It depends.
Yeah, because it would be cool if you could just, harness the lightning to fertilize your field. Yeah, so one other weird lightning phenomena that I stumbled across on the internet is lightning balls. So lightning balls are a rare event only witnessed by a few hundreds of people in history. They usually see a glowing sphere representing lightning, typically during a thunderstorm. The balls can be from the size of a pea up to a football or even meters in diameter. They can see them inside, outside, and there's a lot of contradictory observations, so for a while people weren't really sure if they were real or not.
People thought that it was hallucinations caused by magnetic fields during storms, but that theory is a lot more disputed now. So sometimes they act really bizarrely, they're unpredictable. Sometimes they explode, or sometimes they'll just fizzle out into nothing. They'll hit walls, move at weird angles, and most of the time, a lot of the time, they're seen indoors as well. So they're really rare, so catching these things on camera is difficult, but there are a lot of reported sightings and a few videos, a few fake, but some have actually been authenticated. There's a lot less speculation that they actually exist now, and people are just trying to figure out why that they're occurring. So one of the first sightings that really kind of stands out to me in 1638, a lightning ball in Devon, England. So it was a stormy October morning, and people were in church. There was over 60 people in church, and an 8-foot ball of fire came into the church through the window. It killed 4 people. It injured 60 people because it set fire to the building at the same time. So a lot of people died that day.
I don't think I'd be going back to that church if if I saw that.
No.
Maybe a sign to change religion.
Oh, I don't know about that. Can't say things like that, Pope.
Yeah, I imagine in the 1600s that would have been quite a thing to witness.
Definitely biblical.
I mean, today it would be shocking to see that today, but
it was all over the newspapers at that time, as you can imagine. So yeah, a lot of people thought they were hallucinations, but the skepticism began to sort of go away around about 1963. So this is when a group of scientists were flying from New York to Washington, and when they were on the flight down the aisle, a blazing orb drifted down the aisle and apparently disappeared through the rear of the plane. So this started to convince a lot of people, and obviously public opinion began to change about this phenomena that people were experiencing.
So basically, once a group of scientists saw it, then people were like, okay, that's credible. We can...
Yeah, we trust these people. And then, by some crazy stroke of luck, a few scientists were out, scientists from China Northwest Normal University, they were out recording a conventional storm, just generic lightning strikes, and they were using cameras and spectrometers. And so one of these ball lightning phenomena came out of nowhere. It was just after a lightning strike, and they managed to record it as it moved 10 meters horizontally. Then it went up, and then it just disappeared.
Wow.
And so it managed to give them some crucial data. So the spectrometer, it detected silicon, iron, and calcium in the ball. And all of them were present in the local soil as well. So... interesting.
Yeah, that's amazing luck for that team of scientists.
Mm-hmm.
Okay, so in this case, they identified elements from the soil that were inside the lightning ball. So what does that actually tell us? Like, did they kind of suggest then how the lightning ball formed?
See, that's interesting to me. And really, it's one of the big theories that these lightning balls can pass through windows. But if these different elements like silicon and iron were found, then how could that be possible? How could they pass through another object? It doesn't make sense.
Yeah, it's a strange thing. I also saw some theoretical explanations for these ball lightning. One suggested that it's not really lightning, but just kind of a magnified ball of collected light. It's kind of like a bubble that light gets sort of trapped inside.
Mm-hmm.
And once enough light is trapped, it starts glowing. And it basically can be trapped because around the edge of this light bubble, the air is quite compressed. And somehow this traps the light in there.
I mean, just imagine what a breakthrough it would be if we could somehow harness that energy, use ball lightning in our favour, and essentially have our own mini sun, I guess. It'd be amazing.
Yeah.
Just throwing a curveball there, but imagine that.
Don't look at the lightning ball.
Instead of light bulbs, you could just have a ball lightning phenomenon.
Have a little ball lightning chilling in the ceiling.
Just hugging the ceiling.
Yeah, maybe.
Yeah.
I mean, that's one theory, but it doesn't explain all of the observations that people made. So, for example, a lot of people documented that after the lightning ball has gone, there's a sulfury smell left behind, which, could maybe due to some elemental composition inside it, sulfur, for example. But if it's just light, then this doesn't really explain that at all. One other theory that I read about, and there's a group conducting experiments in Germany, and they, think it's some sort of plasma ball and they were doing these experiments where they sort of using a lot of high voltages in water, get this plasma ball to rise off the top of a surface of water. Yeah, it's kind of interesting. Like there's a fair bit of research going into these ball lightnings now, which is something that I'd never heard of before a few weeks ago.
It's fairly niche, isn't it?
Yeah, quite niche, but yeah, I mean, like I say, you never know when you explain something not understood yet in science where that could go, whether that could potentially have applications.
Yeah, sure. So there was a theory back in 2012 which was trying to explain the birth of so-called ball lightning. So the presence of glass might contribute towards the generation of ball lightning, because there's been so many sightings of like these 10-centimeter balls of light, and they last up to 20 seconds. They move at walking speed, and they tend to occur inside of their houses and vehicles. This is where the phenomena starts to kick in, because this isn't it does occur normally during storms, but these balls of lightning are essentially appearing in people's houses. So the study details a navigation crew that witnessed 2 ball lightning sightings. Oh, try saying that twice. Ball lightning sightings. Yeah, so they witnessed 2 of them. And they happened to witness one of the rarest phenomena twice, which is quite a miracle.
I know. I'm jealous. I want to see a ball lightning.
Yeah, to just see it once in your life would be amazing, but imagine seeing it twice. Wow. So the first time they saw this ball lightning occur, it happened at the cockpit of the plane, and it was during a thunderstorm, so I suppose you'd expect it to happen. But the second time that they witnessed it, there was no lightning activity outside of the plane, and it was very unusual for the staff to see. So there's quite a few cases in quite a few studies where the generation of ball lightning tends to go hand in hand with windows. So in houses, during thunderstorms, right near the window, you'll find that lightning tends to, this ball lightning tends to be where it generates,
Yeah, it's super cool. Yeah, I hope it's something that gets worked out in our lifetimes.
Yeah, definitely. And believe it or not, ball lightning can actually occur in completely different conditions. Take, for example, earthquakes. So from a distance away from an earthquake, you can give off a bit of a light show. You're going to get bright flashes, orbs of ball lightning, and also bluish flames, which are visible in a lot of earthquakes as well. In 2014, a study was done into these earthquake lights. Researchers concluded that certain rocks tend to release electrical charges when a seismic wave hits, kind of sparking a colourful light show for you. Yeah.
Yeah, and I think this is again just like another electrostatic build-up. So the kind of 2 different layers of rocks, kind of one gets positively charged and one negatively charged as they kind of grind against each other when there's either tectonic plate movement or these vibrations from the earthquake in the rocks. And this can, like you say, induce all these kind of weird lights coming out of rocks, which also sounds spectacular.
So ultimately, we don't really know what causes ball lightning, and it's not something that we can generate ourselves. So for the time being, it's going to stay a mystery until somebody manages to crack it. But with modern science, you never know.
You never know. I think, it'll just be like, if there's more random luck of people managing to observe these super rare events, then just need a bit more luck.
Mm-hmm. So we know that orb lightning and strange lightning can occur in loads of different situations, earthquakes and even volcanoes.
Yeah, exactly. Volcanoes are, again, just kind of creating these perfect conditions for lightning in the air. So they release a lot of ash particles, water vapor, these things that can get statically charged up in the clouds. And then, you can find a lot of cool photos online of a volcano erupting and a thunderstorm happening above it. So maybe all this talk about lightning has got you wondering what actually happens to you if you get hit by lightning, and is it certain death or can you survive it? Of course, we don't recommend that you go out and try to get hit by lightning, but it is only fatal in maybe 10 to 30% of cases, and there are quite a lot of lightning survivors. I actually have a friend that was hit by lightning, so this is the conversation I recorded of me talking to my friend, Sophie Frost. Thanks for talking to us today about your experience getting hit by lightning. How old were you at the time when you got hit?
I was 14 years old, just going on 15, so it was quite a while ago.
And do you actually remember getting hit by lightning, or do you just know what you were told afterwards?
So my memory for about like a week before is a bit blurry, or was a bit blurry. I got bits of my memory back, and I can't remember actually getting hit either. And up to like a couple of hours after, I was like blacking out. So a lot of it is just, blank. It was literally going from like one thing to the other. So
can you describe for me like what actually happened, like leading up?
We were hanging out at this park where I lived, and I remember like all the clouds were like coming over together, and they were like super weird looking. We were all commenting and like taking pictures of it because they were sort of like purpley coloured. And then it started raining and all my friends went home and I had to wait for my bus. And the boy that I was with at the time was just like sitting waiting with me. And, as you do in a storm, we sat under a tree, which I don't recommend anybody do. And we were just sitting under the tree listening to music, and then everything is blank. And then apparently this is what happened. I can't remember. My boyfriend at the time said to me, basically I woke up and I was just shouting to him, "Where's my shoes? Where's my shoes?" Because my shoes had blown off, because my feet were like a pressure cooker and the heat just popped them off. And then he picked me up and dragged me into the road and tried to flag down some cars, and a lot of cars just drove past because I think they just thought we were a couple of drunk teenagers. Bearing in mind, I had like completely ripped clothes as well because the lightning had just torn open my clothes. And then he managed to flag down a car, and then this is the first thing I remember was being in the car and pulling out the wire of my chest, because my iPod that I was wearing at the time, the wire had melted into my chest, and so I pulled that out and I was like, "What's this?" And then everything's blank again for me. And then the next thing I remember, I was just in the emergency room, just screaming my head off. And then
oh my God.
I got moved into one of the wards finally. And I wasn't like in a lot of pain. I was just more in shock. The only injury I had was where my headphones had melted into my chest and my stomach. So that was quite sore, but the hospital just left everything inside of me because they didn't know what to do because they'd never had someone come into the hospital being struck by lightning. So I was left there for a couple of hours, and then I got moved to another hospital. Obviously by that point my memory was completely fine and I was remembering everything. I wasn't in and out. It was literally just, I was fine except for my burns, essentially.
Yeah. So this thing with the headphone wires, I remember you telling me that this actually saved your life somehow, right?
Yeah, well, they think that. Obviously, it was all speculation. When we actually contacted Apple, they wouldn't really say anything. They just said, thank you for letting us know, because I think, it could have attracted it or it could have saved my life. And they probably didn't want either, the worst outcome.
Yeah, they don't want a lawsuit on their hands.
Yeah. So when I was wearing my headphones in one of my ears, and so basically lightning wants to find the fastest way to the ground. So it went through the tree and then went through my head. This is what they think. And then obviously because the headphones with the metal, it's a better conductor than what my body would be. So it went through the headphones, missed all my internal organs, and then back through my legs. So that's where all the headphone had melted into my stomach and chest. And then through my legs, if you looked at the bottom of my ankle, it's only there for up to 72 hours. You could see where the exit point was. Because when you get hit by lightning, you get this thing called Lichtenberg figures. I think I'm saying that right. But it's where you only get it if you've had an electric shock, but it's where all the capillaries in your blood vessels pop out to the surface of your skin, and it makes sort of like a fork lightning image on your body. And so I had that on my leg, and then you could see the point where the exit wound. I say wound, it wasn't a wound, but the exit point was on my body. So yeah, I think it saved my life.
Yeah, incredible. And did you get your shoes back?
I did get my shoes back. They were fine. My clothes otherwise were not fine. Both my shirts that I were wearing had big burn marks in them, and also my trousers were ripped all the way down. So yeah, my shoes were fine. My watch was fine. My iPod, however, was not fine. My nan had only bought it for me a couple of days before, and that was blown to smithereens. We went back to the park a couple of days later, and after I got out of hospital, and we found little bits of dead iPod shuffle just dotted about.
Well, it did its job, I guess. Wow. Okay. And do you still have any lasting symptoms till today?
So I'm a little bit, I wouldn't say hard of hearing, but I find it a little bit more difficult to hear on my right ear. It's just a little bit noticeable. I can hear someone better if they're on my left side. It's because I had a perforated eardrum. And also, apparently, if someone's looking at my eyes, I've got a line in my eyes, a bit like what it would look like if you had cataracts, but it's not. Well, that's what the doctor said when I was I don't know if it's still there, but that's what the doctor said to me when I first went in. But otherwise, no, completely fine. I don't have any superpowers or anything like that I haven't told you about. So
Secret superpowers.
Yeah.
Okay.
I was giving everybody electric shocks though for the first week, which was interesting.
Really?
Yeah, just not everybody. That was a bit of an exaggeration. When I was walking past a few people every now and then, I gave someone a little bit of an electric shock. It was just a little bit noticeable.
Oh, and why was that? You were just
lasting.
good at getting charged.
Yeah. Just so charged with this 300,000 volts of lightning. Yeah.
Okay. Didn't you have tinnitus as well, or is that
Yes.
kind of gone?
Yes, I do have tinnitus. But it's just sort of always there. I don't really notice it anymore.
Yeah. You're kind of coping with it.
Yeah, it's not, I think it's just because it's always there. So there's never silence. It's just sort of a low, tiny ring in my ear.
How do you feel about lightning now? Are you scared of it, or?
Not really. There's more chance of me winning the lottery, so I'm hoping that my chances go in that favour. That I win the lottery and not get hit by lightning a second time. Yeah, I'm not scared of it. I'm always a bit thankful when I hear stories about people who have died being hit by lightning. There was that little boy a few weeks ago, I think, or a few months ago, playing football, and he got hit by lightning, and he sadly passed away. And so sometimes when I hear stories about that, I'm quite thankful that obviously I was more lucky. And also upset, obviously, for the families. But it doesn't really scare me. I always get like thousands of text messages saying, "Stay inside, Sophie." I'm a little bit smarter than I was back then. I'm not going to be sitting under any trees anytime soon. So, I feel like I'm the normal amount of worried.
What happened to your ex-boyfriend that was with you at the time? He didn't get directly hit by the lightning.
No, so we were holding hands, but he didn't get like directly hit. He had a bit of like sort of burns in his eyes from the flash, and he was walking around with like sunglasses for a long time, but otherwise he didn't have any injuries or anything. I think they checked him over in the hospital, and then they sent him home. I was the one with the lasting injuries. Is there anything else you want people to know about from your lightning experience? The best thing to do, apparently, when in a storm is to go in the middle of a field and lay flat. So do that and don't sit under a tree, or ideally stay inside. Or always make sure you go out wearing an iPod. That's not also a promotion for Apple.
Yeah, I think we're going to get sponsored now. Thanks very much for sharing.
You're very welcome.
So the best thing you can do to keep safe during lightning storm as well, I suppose, always check the forecast before you head outside. So if you know you're going to be outside for a long period of time, then it's probably recommended that you check the weather. I don't know.
That's true, although it is quite hard to predict a thunderstorm. Like, normally, you in the summertime, you can kind of feel it's super humid for a few days and everyone kind of knows a storm is coming from experience, but it's still a hard thing to predict.
So the best advice is if one does kick off, then get inside as quickly as you can. And if you can't get inside, then a car is recommended, but it's better than nothing anyway. It's not safe, but it's a lot more safer than being outside.
Exactly, because if the lightning hits the car, then it should just get conducted around the outside, which is metal, and not into you, which should be insulated inside.
And if you're really worried, and if them strikes are getting closer and closer to you, it's best to get as low to the ground as possible, because you really don't want to be the tallest thing around in a thunderstorm.
Okay, so once you're inside, what are you safe now, or should you still maybe avoid certain metallic things that are connected to the outside?
Nah, make yourself some toast with your toaster. Definitely stick the kettle on.
Just stick your hand in the toaster.
Nah, just put it straight in the plug socket.
Okay, being serious now. You're probably pretty safe, but it's best to stay away from stuff like corded phones, computers, and any other electrical equipment that's plugged into the wall, because that could potentially, conduct the lightning shock into you, should it hit the building.
Yeah.
Also, it's best to avoid plumbing, including your sinks, baths, and faucets, so probably don't take a shower just yet until the storm's passed. And yeah, stay off your balcony, stay off your porch, because then you're just outside again, aren't you? Stay away from windows and doors. If your building has some walls that are made out of concrete, try and stay away from those because they can occasionally explode.
Anyway, have a great day.
Thanks for listening to the first episode of Real Science Questions. You can find us on Twitter at RSQ Podcast, or if you'd like to send us a friendly email, please do that at rsqpodcast@gmail.com. Thanks and have a great day. The podcast where we obviously ask questions about science that are real.
That are real? We swear we're not conning you with fake questions. These are real ones. Diving deep into ball lightning. Also got balls deep.
Lightning balls deep.
Stop it. I really want to put a balls deep put in there, but I think it's too early if this is going to be out of this podcast and it's within the first 20 seconds.
It just sounds terrifying.
That should actually be how we end it. Anyway, have a great day.
Never leave your house.